and this video is going to be about the reverse power rule, which is used in integration. So what is the reverse power rule? Well, basically what the reverse power rule means is that the integral, or the antiderivative, of x to the power of n dx is going to equal to x to the power of n plus 1 over n plus 1 plus c, where x cannot equal -1. So this right here, this is basically the key. And if this is the only thing you're interested in, and knowing this, then I guess this is all you have to really know. But if you want to see the kind of proof and some examples, then stick around. So this is not a big proof. It's more like going the reverse pathway and seeing if it works. So basically the integral is the antiderivative, right? So therefore the derivative of the integral should give you the function that you're integrating, if that makes sense. So basically, to kind of prove this to ourselves that this works, we can take the integral right here, we can take the derivative of it. And if this is true, that this is the integral of this function, then the derivative of this should give us this function, is what I am trying to say. So, the derivative of x to the power of n plus 1 over n plus 1 plus c. Well, we know that c is a constant, so that's not even going to be part of the problem. And for the x plus 1, we can just use the power rule. So it would be n plus 1 x, n plus 1 minus 1 is just n. And then n minus 1 is not affected by x whatsoever, so we just keep it. And then plus c doesn't exist. N plus 1 and n plus 1 cancel out, right? Do you see where I'm going? And what we have left is x to the power of n. So we can safely say, now that we've kind of proven it to ourselves, that whenever we have x of n, the antiderivative, or the integral of x of n, is this, and vice versa. Alright, so now that we have this out of the way, let's do a couple of examples. Alright, so our first example is going to be taking the integral of x to the power of 4 dx. So this is like a really straightforward example, and you just have to refer back to this, or more specifically back to what we stated here. And we have, the answer would be x 4 plus 1 to the power of 4 plus 1 over 4 plus 1, and we must not forget the c. So x to the power of 5 over 5 plus c. That's it. This is really simple. This here is our answer. Alright, what about a second example? For a second example, it's going to be a bit more complex because we're going to have a scalar in it. We're going to have the integral of 3x to the power of -2 dx. And this is going to give us, so whenever we have an antiderivative or an integral, which are the same things kind of, we can take out the scalar. So it will be 3, the integral of x to the power of -2 dx. And then we go from there. So what did we say? It's going to be 3 x to the power of -2 plus 1 over -2 plus 1. That's going to give us 3 times x to the power of -1 over -1. that's going to give us 3 over -1, -3, x to the power of -1 plus c. Don't forget the c. This can also be written as -3 over x plus c, but in my opinion, whenever you have it written like this, it's easier. All right, so this is our answer here, and it's the same thing. All we had to do is just take out this scalar, and we can do that. All right, moving on to our third example out of 4. We have the integral of simply x. I thought this would be kind of funny to do because, well, you'll see why. So the integral of x is x to the power of, well, x is just x to the power 1 plus 1, over 1 plus 1. So it's going to be x to the power of 2 over 2 plus c. And why I wanted to do this is because this is a linear function, right? X. If you imagine x on the graph, it would look something like this, right? And the area of it is a triangle, right? So this point, x and y, they're also the same. So it's going to be a triangle that's isosceles, so these sides would be the same. And what I'm trying to say is that you just derived the formula for the area. Here there's a constant. Here I didn't draw one, but if it was a constant, it'd be just something like this. And then you're adding on whatever value you have over here. Because the area of a triangle is these side lengths squared, height, and base. This is our height. And then divided by 2. And kind of like you can see it's squared. That's why, squared. Alright, so I thought this was kind of cool. Okay, I promise. Last example. We have the integral of 5x to the power of 1/3 dx. So, once again, we take out the scalar. So we have 5 times the integral of x to the power of 1/3 dx. So once again, we add 1 to the exponent, and then we divide by the exponent plus 1. So we're going to have 5 times x to the power of 1/3 plus 1 over 1/3 plus 1. So basically what we have is 5 times x to the power of 4/3 over 4/3. And to simplify this, well, plus c also. To simplify this, we can just, first, let's figure the situation out. We just divide by a fraction, so we reverse the fraction and multiply it. So we have 5 times 3x to the power of 4/3 over 4. And then we just times 5. So it's going to be 15x to the power of 4/3. All of that over 4 plus c. Alright, so this is our final answer. And this is also the end of the video. So I hope you are more familiar with the reverse power rule and can use it for integration. These were some pretty basic examples, but this rule will come in handy later on, I promise, as well. And I hope you now understand kind of where this comes from and why this is the power rule, and you're convinced now, because sometimes when you're just giving a formula with no explanation, you may not be convinced, but I hope this part kind of convinced you enough. And then, yeah, I hope you enjoyed. Thank you for watching.